Okay, today we're gonna excuse me. We're gonna finish up with solving inequalities. And we're going to talk about absolute value equations. All right, so we talked yesterday a little bit about solving inequalities, and we basically said that you treat the inequality symbol just like an equal sign, unless you have to multiply or divide both sides of the equation by a negative. And when you have to do that, you have to change the direction of the inequality. So let's do one more example here of -3, and we got 2x minus 5. And plus 1 greater than or equal to 4. All right, so more of a multi-step inequality. So what we're going to do right here, first off, subtract 1 from each side. All right, that gives us -3 times 2x minus 5 greater than or equal to 3. And now you got to distribute this -3. All right, so the -3 times the 2x is -6x. And the -3 times the -5 is +15. And that's still greater than or equal to 3. So then we're going to subtract 15 from each side. And this -6x is now greater than or equal to 3 minus 15. -12. All right, and now, this is where you got to be careful. You're going to divide both sides by -6. All right, and however or whatever you need to do to remember, like maybe as soon as you write divide by -6 on both sides, you change the direction right now. So do it first instead of doing it last. And now your 6's cancel, your x falls down, and your -12 divided by -6 is +2. Okay? So that's a real important step right there, because you could potentially do all this work and do all of the math correct and forget to change the direction of the inequality and still get the problem wrong. So whatever you have to do to remember that when you divide both sides by a negative or you multiply both sides by a negative, you got to change the direction of the inequality. So then we're going to graph this. And we've got 0 and we've got 2. It's or equal to, so it's a closed circle. And we are going, the variable's on the left, so we're going the same direction as the inequality. Right here, be careful. Here to here. All right, the other type of problem you'll see on your quiz tomorrow the directions will be, is the inequality always, sometimes, or never true. That will be the question that you're asked. And then you'll be given an inequality. So let's take a look at negative 2 times 3x plus 1 is greater than negative 6x plus 7. All right, and in this case, when you're asked if the inequality is always, sometimes, or never true, you just start to work the problem out. So we're going to do the distributive property here. Negative 2 times 3x is negative 6x, and negative 2 times 1 is negative 2, greater than negative 6x plus 7. So now, if you move the variable next, and some of you will recognize this right now, if you add 6x to each side, you're going to get these 6x's cancel, and so do these. And you're going to get negative 2 is greater than 7. Now, since negative 2 is never greater than 7, you're done. And the answer is never. All right? This inequality is never true. If you get to a step in the problem where a value is never greater than or less than the other value, that tells you the answer to this question. Okay? So there's an example of a inequality that's never going to be true. Let's look at one like 4 times 2x minus 3 is less than 8 times x plus 1. All right, so we're going to distributive property again. So 4 times 2x is 8x. And 4 times negative 3 is negative 12. And that's less than 8 times x, which is 8x, and 8 times 1, which is positive 8. If you subtract 8x from each side, what you're left with is negative 12 is less than 8. Now, negative 12 is always less than 8, so this inequality is always true. And what that means is it doesn't matter what value you put in for x, the inequality will be true. In a never case, it doesn't matter what value you put in for x into this inequality, it will never be true. Okay? So if you get to a step in a problem that's untrue, then the inequality is never true. If you get to a stage in the problem like this right here, well, then the inequality is always true. And now if you get to a step in the problem and you finish the problem and this is your answer, that is an example of always. No, I'm sorry. That's an example of sometimes true. All right? When you get what I'll call just a normal looking answer, this would be sometimes true. And the time that it's true is when x is less than or equal to 2. Okay? So, to try to make sure you completely understand this, we're going to do a little chart. Okay? So let's do it. We'll do sometimes. We'll do always. And we will do never. All right, examples of sometimes, examples of always, and never. So, sometimes true, that's x greater than or equal to 3. All right. If that's your solution, then the inequality is true sometimes or sometime. Always would be like 2 is less than 5. 2 is always less than 5, isn't it? All right, so that equation is always true. Never true. How about -3 is greater than 4? -3 is never greater than 4, is it? All right, so that inequality is never true. M being less than or equal to -5, that's a sometimes true. Anybody want to give me an example of a always? Maybe a little class participation? I don't know. Say it again. 6 being greater than 3. Very good. You get to that step in the inequality, you can stop and say that the inequality is always true. How about another example of never? Never true. Say again. 82 being less than 2. Never true, is it? Okay. All right, so any questions on that? All right, 2 other inequalities to talk about today. They're called compound inequalities. Compound inequalities. Are formed by joining two inequalities oh boy with the word and or. So we're going to solve an and inequality first. And what an and inequality looks like is 7 is less than or equal to 2x plus 1, which is, and 3x is less than or equal to 18. Compound inequality. And what you do here is you just solve both inequalities, and then your graph of the solutions is going to go on one graph. So right here, we're going to subtract 1 from each side. And 7 minus 1 is 6 is less than or equal to 2x. Going to divide both sides by 2. And 3 is less than or equal to x. In the second part of the inequality, that's a one-stepper. We're going to divide both sides by 3. These 3's will cancel, and your x is less than or equal to 18 divided by 3 is 6. So you got x less than or equal to 6, and you got 3 less than or equal to x. So on your number line, follow the rule that we talked about earlier this week. We can put 0 on the number line, we can put 3, and we can put 6. Now, 3 less than or equal to x. It's or equal to, so we're going to close the circle on the 3. The variable's on the right, so we're going to shade opposite the direction of the inequality. Inequality is pointing left, so we're shading to the right. Now, since x is less than or equal to 6, we're closed on the 6 again. We're shading to the left. So all of the solutions to this compound inequality are between 3 and 6 inclusive. That means we're going to include the 3 and we're going to include the 6. And everything in between them is also a solution. Typically, when you see the word "and" in the inequality, you're going to be shading between the solutions. Okay? The other type of inequality that you'll see is a compound inequality. And in this case, it will look like 7 plus k greater than or equal to 6, or 9 plus k is less than 3. And again, it's all one problem, and you're just going to solve both of the parts of the compound. So if we subtract 7 from each side, then we get k is greater than or equal to -1. If we subtract 9 from each side, then k is less than 3 minus 9, that's -6. So when you graph these solutions, they're going on one graph again. On the graph, the -6 is further to the left than the -1. So we are greater than or equal to -1, so we're on the -1 and we're closed. Variables on the left, so we shade the direction of the inequality. We're going to the right. We are less than -6, so we're open on the -6. Variables on the left, so again, we're shading the direction of the inequality, so we're shading to the left. All right, and again, typically when you're solving an or inequality, oh, come on, turn blue for me, then your graphs of the solutions are going to be working away from each other. All right, so any questions on that stuff that we've talked about today? We're wrapping it up with inequalities, and we're moving on to absolute value stuff next week. All right, so as a reminder, there is no Zoom meeting tomorrow. Study guide will be on. You guys in class will get one handed out. Study guide will be under resources tab. The notes for the study guide will be on YouTube. All right, no Zoom meeting. You guys that are in class, the sub will give out your study guide, and then you can go on your phones or devices, put your earbuds in, and you can get the notes for the study guide off YouTube. Quiz on Friday. All right, so I didn't get a chance. We had a department meeting this morning. I didn't get a chance to get to the copier. So I'm going to have to handwrite these equations for you, and you're going to have to just copy them down. So here we go. Here's your assignment for today. This is practice. Four, 2, 3, 21. These are going to be numbered weird because I just got to number them the way that they are in my book. So don't pay much attention to that. When you write these down, if you just want to skip about 4 or 5 lines between each problem, you'll have room to do your work and you won't have to recopy them. So let's do this. We're going to solve and graph. I'm not going to skip any space because I don't have to work these out. But again, I would skip space, kind of like a bunch of space if I was you. And then we're going to be back to solve and graph. Okay, that'll be it for today. You guys in class are going to put those in the basket when you're finished. You guys that are at home, we're going to take a picture of it, email it to me at the end of the period. Once you get the problems copied down, if you're at home, you're excused from the meeting. And actually, with all the notes for the study guide going on to YouTube, there won't be a Zoom meeting Friday either. It'll just be a quiz day, regular quiz day. So our next Zoom meeting won't be until Monday. So if you have any specific questions, you can email me. If you don't have any questions, study guide tomorrow, quiz on Friday. Have a great weekend. We'll meet again on Monday. Does everybody have those copied down here in class? Okay. If you're at home and I'm going to end the Zoom meeting and you don't have all these copied down, they will be on YouTube shortly. So I'm going to stop this meeting now so I can upload the notes.